In section 8.3, we're going to be discussing additional geometric ideas like perimeter and area. So in this section, you will learn about perimeters of different geometric shapes and how to calculate the area within different geometric shapes. The perimeter P of a two-dimensional figure is the sum of the lengths of the sides of the figure. The area, A, is the region within the boundaries of the figure. Here are some typical formulas for the areas and perimeters of several geometric shapes. For example, we have a triangle, and you can see that we have three sides of a triangle, and the perimeter is just the addition of the three sides. The area is 1/2 the base of the triangle times its height. For a square, the perimeter is just 4s, which is 4 times the side of the square. The area is equal to its side squared, which is side times side. The rectangle has a length and a width to it. So the perimeter is twice the length plus twice the width, and the area is just the length times the width. A parallelogram has a base and a width, and the perimeter is twice the base plus twice the width, and the area is just the base times the height. And the trapezoid has two different bases, B1 and B2, and it has two sides, S1 and S2. And so it's just the sum for the perimeter, it's the sum of S1 plus S2 plus B1 plus B2. And for the area of a trapezoid, the area is 1/2 the height of the trapezoid times the parentheses of the addition of the top plus the bottom of the trapezoid. So here's our first example of using some of the ideas of area and perimeter. Rob Marshall wishes to replace the grass sod on the lacrosse field. One pallet of Bethel Farms sod costs $175 and covers 450 square feet. If the area to be covered is a rectangle with a length of 330 feet and a width of 270 feet, determine 1a, the area to be covered with the sod. So the solution in this case, since we can draw a picture, and here we have a rectangular area with the length of 330 and the width is 270, we can see that the area is the length times the width, which is just 330 times 270, which on our calculator will give us 89,100 square feet. So in the same example, we want to also determine how many pallets of sod Rob needs to purchase. The solution is the area to be covered, which is 89,100 feet, divided by the area that can be covered by one pallet. In this case, it was 450 feet. If we divide 89,100 by 450, we get that we will need 198 pallets of sod. Now our final question. Determine the cost of the sod to purchase. So the solution is we take 198 and we multiply it by 175. When we do that, we get a solution of $34,650. So it will cost Rob to resod the lacrosse field $34,650. One of the most important theorems in mathematics is called the Pythagorean theorem. The Pythagorean theorem is the sum of the squares of the lengths of the legs of a right triangle equals the square of the length of the hypotenuse. So we have the leg squared plus another leg squared is equal to the hypotenuse squared. Symbolically, if we have A and B represents the length of the legs and C represents the length of the hypotenuse, then we have A squared plus B squared is equal to C squared. You will notice that this is our triangle that we are looking at, and so this is the relationship of the equation called the Pythagorean theorem. Now we're going to use the Pythagorean theorem in crossing a moat. The moat surrounded a castle is 18 feet wide, and the wall by the moat of the castle is 24 feet high. If an invading army wishes to use a ladder to cross the moat and reach the top of the wall, how long must the ladder be? So we draw our picture here. Here's our picture. We have one side of our triangle to be 24 feet, and we have the other leg of the triangle to be 18 feet. Now we're trying to find the length of our ladder, C. So if this is A and this is B down here, then we know immediately we can use the Pythagorean theorem and that's what we're going to do. So here's our solution. C squared is equal to A squared plus B squared. Well, now we have 18 feet, which is A squared, and B is 24 feet, which is 24 squared. We add those two numbers together, so we go from here, we plug in the numbers, and now we get these two numbers, and we're going to add them together, and we get C squared is equal to 900. Now we take the square root of both sides of the equation. When we do that, we get C is equal to 30. On your calculator, you'll see a square root symbol, and you can put 900 in and take the square root symbol and hit the equal sign, and you should be able to get the answer that we have here. So in this particular case, the ladder needs to be at least 30 feet long. A circle is a set of points equidistant from a fixed point called the center. A radius r of a circle is a line segment from the center of the circle to any point on the circle. So here is our radius, but we can have a radius here as well. The diameter d of a circle is a line segment through the center of the circle with both ends of the point on the circle. So d really is a line that goes from one end of the circle to the other end of the circle. So for the circle, the circumference is the length of the simple closed curve that forms the circle. It is the length that goes completely around the circle is called the circumference. And to find the circumference, there's a formula. That is, C is equal to 2 pi r. Pi which we call a transcendental number, is approximately 3.14159 ... In other words, it goes on non-repeating forever. However, we're just going to use 3.14 as our approximation to pi. The area for a circle is, the area is equal to pi r squared. And again, pi is approximately 3.14. You have a pi button on your calculator which you can use, and then you can round up from there to 2 decimal places. So now we're going to make use of this idea of area. So in example 4, we're going to determine the area of the shaded part. So to determine the shaded area, use the pi key on your calculator and round your answer to the nearest hundredth. So in this case, we see that we have a radius of 2 feet for the circle that is inscribed into a parallelogram, which has the base part as 10 feet. So now we want to figure out, well, what's the height of this parallelogram? Well, you can see that the height of the parallelogram is going to be 4 feet. Do you see why? It's going to be twice the radius. So now we're going to find the area of the shaded area. So again, the height of the parallelogram is the diameter of the circle, which is 4 feet. Now, because we know the height and the base of the parallelogram, we can find the area of the parallelogram. And the idea is, or our strategy is, we then can find the area of the circle, since we have the radius, and our idea will subtract the area of the radius from the area of the parallelogram to find the shaded area. So, here we're going to find the area of the parallelogram. We know it's the base times the height. That was one of the formulas that we have found earlier. When we multiply 10 times 4, we get 40 feet. And then we're going to find the area of the circle, which in this case is pi r squared, which is pi times 2 squared, which is 4 pi. And 4 pi, if we do it on our calculator, is approximately 12.57 feet. Well, now, the area of the shaded region is equal to the area of the parallelogram minus the area of the circle. So now, the area of the shaded region is approximately 40 minus 12.57, and that gives us an area of the shaded area of approximately 27.43 feet squared. So please review the topics in Chapter 8.3. We'll be using them more in problem solving in the future. And this is a good chapter for understanding area and perimeters of geometric shapes.